So, hello everybody. Welcome to another one of our Kitronik Tech Talks. Slightly different setup this time. It's the first time myself and Dave here have managed to actually be in the same building.
Woohoo!
So, due to COVID regulations, we're not actually sat next to each other. So
Kev's right at the far end of the building, like miles over there.
we are socially distanced. So yeah, today we're going to cover some of our new products for the Raspberry Pi Pico. Just if people don't know us, I'm Kevin. I'm one of the I guess founders here of Kitronik, and Dave's sort of development director and head designer. So he's designed the products we're going to cover off today. So any tough technical questions, hopefully we can cover those off. And we also do have Mark, who's manning the chat today. So if anyone wants to send us messages, they're welcome to. We'll try our very best to answer those. And if you are watching on catch up later on, then feel free to send us some questions later, and we'll still try and help you out. So hopefully that all makes sense. So Dave,
yes,
what are we going to cover today?
Today we're going to talk about a couple of roboticsy type boards for the Pico, specifically this one and this one. So one is a motor driver board, and the other one is what we call an all-in-one robotics board. So I'll just switch to my other camera, and we'll show you what they are. Yeah.
So the Pico, if people don't know, I'm sure most people do know what it is, but it's a microcontroller board, isn't it? Developed by the Raspberry Pi Foundation.
Yeah.
It's slightly different to a normal Raspberry Pi, which is a computer itself, in that it's there you go, one there. Yeah, that's something it's a codable microcontroller, isn't it? So you use a computer to write some software, you then transfer that software to that board, and that board then runs independently and can interact with the outside world using the I/O connections.
Yeah. So for this, we've developed, this is the motor driver, which is a little tiny board, pretty much the smallest size we could get away with for putting the Pico, which just drops all the way around in the headers. It is marked on the PCB. Put the USB bit, which is the USB bit of the Pico, in this way around. So you need soldered pin headers, and it just plugs in. Yeah. Now I've got a compact motor driver. All the I/O on this board is broken out via these screw terminals here. And we've got screw terminals for the power and an on-off switch. And there's also this little 3-pin connector. In remote control cars and that kind of things, it's quite common to have what's known as a servo receiver pack, which uses a servo plug, which is one of these little 3-pin plugs to power things. And so you can just plug your servo pack straight in there as well.
Okay. And I mean, just so this board would be, you wouldn't need to solder at all, would you? And even the Pico, we do sell Picos with the headers pre-soldered in. So for people who don't have a soldering iron, you could just buy both of these boards and off you go.
You need one of those, a screwdriver. And then you just screw terminal.
Straight in.
Yeah. So the other board, which we're going to talk about tonight, is the what we call the robotics board. So this is 5329, and which I'm very confused with my camera, which way is left and which way is right.
So don't worry, Dave. I'm confused all the time.
That way. There we go. Got it in the middle of the shot. Hooray. So this is slightly larger, as you can see, but it's got a lot of the same common features, just more of them, really. So again, there's the header for plugging your Pico in and the USB marking. Again, there's terminal blocks along this edge here for motors, and this can do 4 DC motors or 2 stepper motors, whereas this one can do 2 DC motors or a stepper motor. And then there's this big bank of pins down here, which are for servos. So your normal hobby servos, even your big chunky servos, and you can just plug them in. Job's a good one. You can drive 8 servos and 4 motors all at the same time from this board, which is pretty good. There's a lot of robotics possibilities you can do with that then.
Yeah.
Slightly different approach on this board because if you're building a robot which has like 4 motors and 8 servos, you're likely to be fairly, I'm going to say not advanced, but really into building your robots. You're likely to be able to solder. So this time we broke out the I/O from the Pico into solder pads. So basically all the spare I/O from the Pico is available for doing other things on your board, whilst this board can take care of all the driving and the servoing.
Yeah, looks really neat.
So that's the 2 boards in a nutshell. You normally show a web page at this point.
Yeah, I'll do that now. So we can delve into each one in maybe a little bit more detail.
Yeah.
So if I just show this here, so hopefully we can all see that fine. Can you see that?
I can see it, yes. I have no idea if YouTube can see it, but I definitely can.
So yeah, this is the web page for that product. As you can see, the motor driver board starts at £7.50 plus VAT. It goes down to £6.25. So it's a really low cost board. And then we have some example pictures of it connected to products, but I'm sure you'll cover that later on.
Yes, we'll deal with those sorts of things in a bit.
There's a whole lot more information on here about that product. And again, there's a video there, we're talking about today, but we do these other videos showing, what the board can do.
The very quick explainers.
Yeah.
Yeah. And
then we also have the other board, which is
5329.
Yeah. So this board's a little bit more expensive. But you can see it again here. This is £11, down to £9 if you buy more of them. And these prices people might notice, but they're exactly the same as the prices for our equivalent boards for the microbit. So we do these similar boards, don't we, Dave?
Yes, that's how we've managed to spin these back out, and we're very confident that they're really good boards because we've done a lot of testing with this particular circuit layout and stuff on the microbit.
Yeah, it's something we've pivoted, isn't it, to the Pico
yes,
board?
Pivoting to the Pico. Perfect.
Yeah, pivot to the Pico. And again, we've got the same kind of information on here that covers it. We've got data sheets and all those kind of things, example code, etc.
Yeah.
I mean, I'm sure you'll cover it later, won't you, Dave? But
yeah, we'll go through the example code in a bit.
Yeah, and that's all available on our Kitronik GitHub page, isn't it?
Indeed, I have those up here actually. So if I share, there we go.
So yeah, I mean, they're not expensive, are they?
So this is the GitHub. So we can go through these in a bit more detail when we get back to the actual boards. But if you go to GitHub and search for Kitronik Limited, you'll find them. We call things company name, processor, what the thing is, what the language is. So these are Kitronik's Pico motor driver board for MicroPython, for instance.
Okay. Great. So I mean, yeah, fully resourced really, these boards. I mean, do you think these products are really designed for education or the maker market, or where do you see these being used, Dave?
If they're in education, it's in the more advanced sort of years 4, 5, maybe 6th form sort of roboticsy type projects. You can build a very nice line following buggy with these. We'll show you a little thing. I've got a hack together one that I've been doing some development work on, which I'll show you. The Pico itself hasn't made it really much mainstream into education yet, but I think it's quite a good board for education because of its price. And with these add-ons at such a low price, then I think they will find their way into schools. But equally, if you're doing like mini Pi Wars type robotics competitions, perfect. Yeah.
So, I mean, with that in mind, then the resources we're providing, I can't see your face, Dave. You're sort of staring at a green board.
I hadn't realised.
We're really kind of
I'm back. Right.
Providing these with data sheets, aren't we? Really showing people how to use example code, and we will be providing sort of online tutorials, won't we?
Yeah. Blog like our normal resources and our blog post resources, and the look at how you could build a thing with this. Here's the stuff you need, and here's how you do it. All that kind of explainer stuff. One of the things I'm doing at the moment, I'll just wave this quickly, and we'll have a look at it in a bit. Is this, which is part of me writing some of that sort of resourcey stuff. Yeah.
So we'll have things like, I don't know, project ideas with shopping lists and example code and showing you how to make something. As time goes by.
We'll try and always ensure, because this is what Kitronik do, that there is an educational thing behind it. Like you will learn a thing. With these, it will be you will learn about motors and how to drive motors. With the Discovery Kit, you learn about how to program code. It's that kind of ethos that drives our product.
And would you need to have any experience of the Pico to use these boards, or there'd be enough to get you going?
No, you shouldn't need to. If I've written the resources correctly, or my team has, then you should be able to pick up the resources, read them, and understand what you're doing, and do it, and have a successful outcome. That's what we try and deliver. Yeah.
And there are a lot of Pico resources out already, aren't they, from people like Raspberry Pi showing you the basics of coding and things. So great. Okay, so we've shown some of my notes on here. We've shown the boards. If I don't have notes, I forget where I am. So so they've all got simple plug and play headers, the kind of things you've shown. Do we want to look at one board in real detail, maybe?
Yeah, we can do. Let me just pull the Pico back out here. These development Picos of ours have got quite bent pins because we're a bit rough with them. There we go, that came out.
Which one are we doing first, the motor driver?
Yeah, let's do the motor driver because it's simpler, and also the robotics board builds on the motor driver board. I missed. There we go. Right, so let's zoom in a bit.
So that chip on there, that's the motor driver chip, then the main one you would see.
Yeah, so I'm going to use this here screwdriver as a pointy thing.
Yeah.
So this chip down here is a full dual H-bridge motor driver chip. That H-bridge is just a technical way of describing how the transistors that drive the motor are laid out. When you draw it on a schematic, it looks like the letter H, and engineers, being the most imaginative sort of people, went, oh, that's an H.
Yeah.
That's why it's called that. So this drives out through these terminals over here, where it's labeled, I think you can see,
motor 1 and motor 2.
Motor 1 and motor 2.
Yeah. So
there's two terminals there. One for motor 1, one pair for motor 2.
And what kind of motor control can you do then? I guess it'd do speed control, brake, coast, all those, forward, reverse.
So you drive so basically the chip is a way of delivering more current to a motor than the microcontroller can deliver. Pico, it's lovely, but it's really tiny. It can only put out about 3 or 4 milliamps, whereas most motors need something in the amp range to drive. So you waggle some pins on the input side of the chip, and the chip translates that to bigger signals on the output side for the motor to drive. So with the Pico, you can do a thing called pulse width modulation, which changes how wide the pulses are, and that effectively changes how fast the motor turns. So you can do full speed control from 0 to 100%. There are brake functions in here. It's also short circuit protected and overcurrent protected. So short pins out, it doesn't go pop or get too hot or anything. It shuts itself down. It's quite safe in that respect. It's good for 1.5 amps per channel. So 1.5 amp motor there and a 1.5 amp motor there. So 3 amps overall. And
is that 3 amps at the maximum sort of voltage you can put into the board then?
Yeah, which is just over 10 volts. It's 10.8 volts. It's labeled again, which we try and make I'm trying to get this the right way up for everybody. That way. It messes with my head because it's out by 90 degrees and also upside down. So we put the important labeling on the board so that you don't lose the data sheet. You've got it always with you. So we've got the input voltage, and which is plus and minus here. We've got which way is on and off for the on-off switch, which is on the end. And then we've also got the terminals labeled on the bottom as well as being labeled on the top there.
Yeah.
So, it's also got 4 I/O pins that you can use screw terminals to get I/O into or out of the Pico for other functions. So the Pico's got loads of I/O pins, hence there's loads of pins. We picked 4 that we thought were the most useful. So we picked GP Norton 1, which are the default UART. So in Pico terms, that means that you can send serial messages up and down them. So if you wanted to talk serially to the Pico, you can use them for that. You can also use them just as a general purpose input, or as, I think they're I2C as well. The Pico's quite flexible in what you can wire to where. So that's why I picked those 2. And the other 2 we picked, 26 and 27, are 2 of the Pico's analog inputs. And they're only available on a few pins, which is why we thought we should break those out. Because if you wanted to read an analog signal in, you can do, and it's simple to wire in. And then on the end here, these last 2 terminals are some power and some ground, so that if you need to power something, you can take some power from here and out.
Yeah.
So that's the motor driver board, and
just so what? So just going to say it powers the Pico as well, doesn't it? So it's got that regulator on it. Yeah.
This little section of circuitry up here is a regulator for powering the Pico, and there's a couple of diodes and things in here so that you can't, because of the way the Pico is built, when you plug your USB cable in from your computer, it turns itself on. You don't really want your motor driver board to be trying to power itself from your computer. So there's a couple of diodes and stuff to block that.
Yeah.
Yeah, I mean, that's pretty much the whole circuit. There's not a huge amount on there in terms of what's there. There's an on-off switch and an LED as well, which I'll show you when we get to the one that's wired up with the battery, because that's easier. Because clearly turning it on, the LED hasn't lit up because there's no electricity.
Yeah.
So if you look closely at the robotics board, I'll just put it slightly out of shot here. You might be able to see that this chip here is the same as this chip here. And suspiciously, this chip here has 4 terminals near it. And then this chip here is the same as this chip over here. And this also has 4 terminals on it. So what we've done is doubled up basically the motor driving section into 2 motor driving sections on this board. But we've done it in a slightly cunning way. The servos require a specific sort of signal to drive them. And this chip here is programmable to allow us to drive that out onto the servos. And we can also use that programmable ability to drive the motor driver chips as well. So what happens is the Pico only actually drives 2 pins to drive all of this functionality, which is why I've got so many breakout pins for all the other I/O. So it lives on a thing called I2C, which is integrated circuit, which is a mouthful to say. But basically, the Python code takes care of all this for you. I mean, you can read the Python code, you can understand how it works, and we will do some resources that explain it all properly and how you'd build it up from scratch, because that's a really good learning experience if you're going into software engineering, roboticsy things. Anything electronical nowadays has multiple buses and all sorts of other jiggery pokery in it. So the Pico only actually uses 2 of its pins to talk to this chip, and then this chip has 16 outputs, 8 of which go to the servos, and the other 8 go to the 4 motors, sorry, the 2 motor chips.
Very clever.
Yeah, it's both very clever and incredibly simple, which is nice. And again, this has got an on-off switch down here, power terminals. It's the same 10.8 volts. The maximum current this board can cope with is 12 amps, which is a huge amount, really. Because you've got so many motors and so many servos, we made sure it could cope with trying to drive a lot of things at once, but you need a big battery to power it 12 amps.
Yeah, yeah.
I mean, you can power it off power supply, and just to give you an idea, this power supply here, which is onkin big thing, is good for 10 amps. So this great big power brick can power this board, and the board can still take another 2 amps off the top of that and not be in danger.
Wow.
That way, zoom back in again. So
I mean, the amount of robotics projects you could build with 4 motors or, stepper motors if you use those instead, and
yep.
And that number of servos, it's significant, isn't it?
Yes, yeah. I mean, 8 servos is more than most people ever need to hook up to anything. We do a 16 servo board for the microbit, but we haven't ported that across yet because I'm not sure anybody ever really needs 16.
No, 8 sounds. I mean, you could do sort of 2 fully functional robotic arms, couldn't you, with one of these boards?
Yeah, with 4 servos on each. Yeah.
Mm. Yeah, so lots of possibilities, really.
Yeah.
Like you say, you could have buggies that drive around, with I don't know, tipper trailers on the back and all kinds of things, couldn't you, with those servos?
Yeah. I had one hooked up to one of our Move Minis the other day just to check that was all a possibility. It doesn't really fit very well. I had to wedge it in. But yes, that's the kind of thing you can do. So shall we do some little things that are wired up? I
think so, because I think we've covered the boards quite well. We've covered the motors, those kind of things. So I think the things we want to show is examples and then maybe some of the software if we get time.
Yeah, well, so this is a very easy, quick example to show really. So this is one of the motor drive boards. This is actually one of our line following buggy chassis that I just hacked about a bit with so I could do some testing. And so the on-off switch is here. And you can see the little green light on the on-off switch.
Yeah, I can see that.
So that indicates the board's on, which is good. And now I've got the Pico programmed with some code, so it starts when it gets power. And what it's doing is reading some sensors on this board, and it's going to turn on and off the motors on this board on either side, depending on which sensor's covered. So if I cover this one, that motor moves, and if I cover this one, the other motor moves. And that's the basis of a line following robot. I took the wheels off it because clearly on the small desk space we've got here, we would have a line following robot on the floor very quickly.
Yeah.
But as you're going along, as you're driving, you can drive both wheels forward and then turn a bit and then turn back the other way and just basically follow the line.
Yeah.
So I've been doing a little bit of work on this for like writing resources and that kind of thing at the moment. And I'm going to move this out of the way because whilst that's an interesting thing, I can show the code with the other board with the setup I've got just here. Let me just zoom out. So what I've got here is, this is actually our test pack of motors, of 4 motors that are all tied together so they don't go anywhere, but I've only wired 2 of them up to the board here. And this is a stepper motor. And people don't seem to use stepper motors. I think some of that's probably because they think they're hard. But they're actually incredibly easy. You just have to remember that what a stepper motor is a pair of motors glued together in the same place. And then, where's the on-off switch? So again, on-off switch, there's a little LED.
Yeah.
See that there?
Yeah, yeah.
So we'll turn it off, LED goes off, LED comes on. So this Pico isn't set up as running the code automatically, but I've got Phony here. So if I share my screen, here we go. So I've got some code here for our robotics board. And if I hit run, see this? Can you see the stepper motor moving?
Yeah, we can. Yeah.
And then the wheels go blip.
So the motor's rotating.
Yeah.
And then once every full rotation, what's the stepper? The normal motors do a short pause, don't they?
Yes. Yeah. I didn't really get time, but I was going to make it so basically the stepper motor loaded something like a paper plane in, and then the wheels fired it.
Okay.
That's the kind of fun robotics project you could do with this board. And I haven't even plugged any servos in yet, so I could have servos doing other things like folding up wings on paper planes or something.
So I mean, that code looks really simplistic there.
Yeah. So that's the thing we've tried to do with both of these is we've hidden all the complexity away a little bit so it's not as intimidating. But so this little line up here called import Pico Robotics is doing a whole load of heavy lifting there. And it's bringing in this file here, which has, I don't know how many lines, but this is all the code that you need to use to drive that board in this simple way. And the nice thing about the MicroPython on the Pico is that I can do this by just saving that file onto the Pico and then importing it into here. And I've got access to all the code that's in there.
Yeah. So that brings in those functions that you're using then.
Yes, exactly. So what I've done here, so in the Pico Robotics, there's a class called Kitronik Pico Robotics. And this is a way of encapsulating all the complexity into a single thing. And then you provide an interface which has various functions like servo right, or turn the motor off, or turn the motor on, stepper motor, and all those kind of things. And by generating an instance of that class, I've now got some code that's running that's got those functions in. So I then call board motor on, and away it goes. So if I change something in here like what's the servo thing called? So the handy thing is that because the code's here, I can't remember the words, but I can go back. That's the motor drive one. I can go back into the code and find out what they're called. So servo right. And then that takes some things. One is the servo, and the other one is what degrees we want it to go to. So let's bung a servo on number 1, and let's set it to, say, 90 degrees. And then down here, just so that we know it's moved, let's set it to, I don't know, 40 degrees, something like that. And at this point, I need to find a servo.
Oh,
here's one.
It's live coding, Dave.
This is live coding. I said I was going to do dangerous live coding. I wasn't doing
it. Does seem so, yeah. Does that servo work?
It should do. It's one of our high quality development servos. So I'll just hold on to it. And now I can just stop that. And if I run that again, step motor steps. This is the moment of truth. And the servo moved.
There you go.
And then see the servo flick there?
Yeah.
So that's how easy it is to code and add extra things to your project here. Like I said, all this code is available on our GitHub. So there's a GitHub for the motor driver board, which has all the code. And there's a GitHub repository for the robotics board. And in here, there's a README file. And the README file tells you what you need to do and how to drive the various functions that are available in the class.
Yeah.
So GitHub's quite scary for people because certainly novice coders, they might never have used it. It's not really very scary. If you want to just look at some code, you can just click on the file. Here's all the code. There's a thing in Git called clone, which gets a local copy of all the code onto your hard disk. But you don't necessarily have to do that. If you hit this raw button, you can just
the raw button. Am I missing something here?
I'll show you. I'll go back to it, but you can just do copy, like highlight it all, copy, and then in Tony, I can just get myself a new thing and do paste. Magic. I've got all that code.
Yeah.
So I'll go back and show where that was because that might have been a bit fast. So do a search for Kitronik GitHub, find the right one.
I don't think we can see that bit, Dave. That's all I'm saying. I think we just see the...
Can you not see the... Oh, I've shared the wrong thing. Thank you, Kevin. I keep doing that. Let me try again. I shared the...
Single screen, yeah.
Come on.
The joys of Zoom.
Oh, you'd have thought by now we'd be better at it, wouldn't you?
I don't think we ever will be.
Right. Can you see GitHub now?
Yep.
Hooray. So you go to Kitronik Limited, search for GitHub Kitronik, and you'll find our repos, which you'll get to a page that looks a bit like this. And there's a whole load of repositories. And in here is all the code that we've released for all of our products. And you can go and look at how the inside of our products work, which is really useful for a learning experience. So there's the motor driver board. And the one I was in was Pico robotics board. So in here, I'll do this again now because now you can see it. There's a README file that tells you how you use the file and then what all the various functions are. So to drive a motor, there's a function called motor on. To drive a servo, there's a servo right, which is the one I use to just make it flick. There's a stepper motor one for number of directions or for an angle. And then if you want to actually look at the code, you can click on the file and here's all the code. If you look at that code, hopefully when I flick to Tony, can you still see Tony?
Yeah.
Excellent. That's the same code as this code. So you can clone, which downloads a whole copy of the code into a directory on your local computer, or you can hit this raw button over here. And that brings it up as just a text file, and you can then just copy and paste to your heart's content out of there into Tony and use it.
And off you go.
Off you go, indeed. So
it does look easy.
That's actually how I managed to get the file here, because I haven't got Git installed on the computer we're using for the live feed, it turns out.
Okay. Yeah.
So no, I don't need to say that. So that's the code and a little bit of magic live coding that worked perfectly. The servo is still twiddling away. Are there any other things that I've missed?
I don't think so. I mean, like you say, they're quite well home boards, these, aren't they? You know, with with the same technology we've used in lots of other products in the past. You know, they will be reliable.
Yeah.
Maybe you can stop that share, Dave.
Yeah, hang on. I'm on it. I'm just trying to find all the buttons.
Yeah, there we go. Dave's back. Yeah, you know, so they're not expensive boards either, are they? So, you know, a Pico, you know, like we know, is sort of £3, £5, depends if the headers are included or not. You know, and these boards are sort of £7 to £11, depending upon the board. Maybe cheaper if you're buying bigger volume. So for quite a small amount of money, you can produce, you know, you can buy something that will allow you to produce quite complex robotics projects.
Yeah, and quite quickly and quite easily. We've written the code in such a way that, well, in my head, and I've got a lot of years of software development, so maybe it's not quite right, but in my head, the code is written in a nice, straightforward, well-explained way. I'm just going to share it again, actually, and just show that one. I'm going to just share Tonic, and I'm only going to show this bit. So in here, all the little light gray bits are comments. The processor doesn't need these. Pico doesn't need those at all. They're there for people, especially for people who don't really know what they're doing. So things like, if you want to read some values, you could do this. And there's actually a little function in here that isn't there that shows you how you could read some values out, which I used when I was writing the stuff initially, so I could check it was working properly. But down here, how to drive a motor. Make sure that we don't try and drive it faster than 100%. So if it's less than 0 or more than 100, sort of stop.
Yeah.
These are all good practice coding techniques, but hopefully all of the code is well enough commented that a novice can read it and then understand what's going on in the code, and from there build their understanding of how to code. So we try and put some effort into the back end bits because we want people to get better.
Yeah. And as we've always said, we're always here, aren't we? You know, our customer service guys, you know, they're actually reasonably quite versed in these things. They can always come and ask us questions if they want.
Only today, Cullen, one of our customer service guys, he dropped me a message saying, I've had this message about the Pico robotics board, this board here that we're talking about. The guy can't get it working, and it's because the import statement, nowhere in the world did it mention that you'll need to save the file to the Pico. So this afternoon, I've written a blog post, which hopefully will go live tomorrow, which explains how that should work and why we do it like that. So it's things like hiding the complexity code out of the way and making your program look simpler and breaking it down into blocks.
Yeah.
Yeah.
Like I say, so if people have questions or want help and things, we are here to help with these products. So I think that kind of roughly covers what we're, well, doesn't roughly, it does cover off everything we wanted to show.
Yeah.
Yeah. And obviously, hopefully we'll do more of these tech talks. We're planning to do them on quite a regular basis. We'll do maybe new products as they come out, but we're also going to go back and revisit some of our sort of more popular older lines that people may not have seen. So yeah, please feel free to subscribe to our YouTube channel. You know, we're doing these on a, like I say, on a regular basis. And if we do have questions, please send them through. I don't think there are any questions that have come through while we've been on.
That either means we're brilliant or no one's watching.
No, people are watching, so
we must
we've got viewers. But yeah, so you know, hopefully that means that you've done a great job there, Dave, of explaining what those boards do. So yeah, thanks a lot, everybody, and we'll see you again at our next Tech Talk.
Goodbye, Internet.
Yes.